So, we just got some huge updates about 3I Atlas, and they are once again raising some serious suspicions about this object. First, Harvard scientist Avi Loeb just published trajectory calculations, and the math is showing something that seems to be statistically impossible. Meanwhile, a researcher filed a Freedom of Information request, asking for any documents about 3I Atlas, but the CIA responded with what's called a Glomar response. That's the same type of answer they give about covert operations and classified programs, not space rocks. But let's first talk about Loeb's calculations. So on March 16th, 3I Atlas will fly past Jupiter at a distance of 53 million kilometers. That specific number might not mean anything to you yet, but Jupiter has something called a Hill radius. Think of this as an invisible boundary around Jupiter, where Jupiter's gravity becomes stronger than the Sun's gravity. Inside this boundary, Jupiter can capture objects and hold them in orbit. Outside this boundary, the Sun's tidal forces are too strong and rip everything away. Well, Jupiter's Hill radius is 53.5 million kilometers. 3I Atlas is passing at 53.6 million kilometers. So the match is within 100,000 kilometers. Sounds like a lot, but for space, that's actually pretty close. Well, Loeb calculated the probability of an interstellar object randomly hitting this close to the Hill radius. He looked at the full range of possible distances you could pass Jupiter. The odds came out to 1 in 26,000. That is a 0.004% chance. But it gets even weirder. The very next day, on March 17th, 3I Atlas will pass extremely close to one of Jupiter's moons. Not one of the big famous moons like Europa or Ganymede, but a tiny irregular moon called Eupheme, which most people have never even heard of. So what exactly is Eupheme? Well, this moon was discovered in 2003, and it's super tiny, only about 2 kilometers across. That's smaller than most mountains on Earth. The moon is so small and faint that after they first spotted it, they actually lost track of it for years. It took 14 years before astronomers found it again in 2017. Finally, in 2019, they gave it a proper name through a Twitter contest. Eupheme in Greek mythology is the spirit of praise and good omen. Eupheme orbits Jupiter in the retrograde direction. That means it goes the opposite way compared to Jupiter's rotation. It is part of what astronomers call the Ananke group. This is a family of 15 small moons that all orbit backwards at high angles. Scientists think these moons probably came from a single asteroid that got captured by Jupiter's gravity billions of years ago and then broke apart from collisions or tidal forces, ripping it up. So, we are talking about a tiny captured asteroid fragment orbiting backwards in a highly elliptical orbit, and 3I Atlas is going to pass right by it the day after threading the needle through Jupiter's Hill radius. Before we continue, please take a second to help me out by clicking the like and hype buttons. Thank you. Now you might wonder why passing near Eupheme specifically matters. Jupiter has 95 moons. What makes this one significant? Well, irregular moons like Eupheme are actually the easiest places to deploy satellites. Regular moons like Europa and Ganymede orbit in Jupiter's equatorial plane. They are locked in stable orbits shaped by billions of years of gravitational interactions. Getting into those orbital spaces requires precise insertion burns. But irregular moons like Eupheme are already in chaotic orbits. This makes them ideal staging areas. The Ananke group, where Eupheme belongs, is especially interesting. These 15 moons probably came from a single parent body that broke apart. They share similar orbits and are spread out along the same general path around Jupiter. So passing near Eupheme is not just a random coincidence of passing near one of many moons. It is passing near exactly the type of moon where you would deploy technology. 3I Atlas will pass Eupheme at 30.46 million kilometers on March 17th. That sounds pretty far, but in space terms, it is actually quite close for an interstellar object to pass near a specific moon. And the timing is weirdly specific. Eupheme's orbit is very stretched out. Sometimes it is close to Jupiter, and sometimes it is far away. On January 23, 2026, Eupheme will reach its farthest point from Jupiter. That distance is 27.7 million kilometers. January 23rd is exactly 52 days before 3I Atlas makes its closest approach to Eupheme. Here is another detail. Eupheme takes about 538 days to complete one orbit around Jupiter, but 3I Atlas is moving much faster. During the time 3I Atlas travels from Jupiter's Hill radius to its closest approach to Eupheme, which is only 1 day, Eupheme barely moves in its orbit, less than 1 degree. What this means is 3I Atlas is approaching from the same direction relative to Eupheme for basically the entire encounter. The geometry stays almost constant, so let me lay this out clearly. An interstellar object is approaching Jupiter at almost exactly the Hill radius distance, passing near a specific irregular moon the next day, with that moon reaching its maximum distance from Jupiter almost exactly 2 months before the encounter, and the approach geometry staying constant because of how fast 3I Atlas is moving compared to the moon's orbital period. These are exactly the kinds of orbital mechanics you would calculate if you were designing a mission to Jupiter. Let me explain why the Hill radius matters so much. This is about basic physics and velocity. At closest approach, 3I Atlas will be moving at 66 km per second relative to Jupiter. That is insanely fast. For comparison, Jupiter's escape velocity at its surface is 60 km/s. But as you get farther from Jupiter, the escape velocity drops. At the distance where 3I Atlas will pass, around the Hill radius, the escape speed is only about 2.2 km/s. Here is the critical physics problem. For anything to get captured into orbit around Jupiter, it needs to slow down dramatically. If you are moving at 66 km/s and you want to enter a stable orbit, you need to lose almost all of that speed. Natural breakup cannot produce the velocity changes needed. When a comet breaks apart because of gravity or thermal stress, the fragments separate slowly. Maybe a few meters cs, maybe tens of meters es at most. In extreme cases, you cannot get anywhere near the 60 km/s velocity change needed to enter orbit. So, what if 3I Atlas releases objects at Jupiter's Hill radius? What if small devices separate from the main body and fire engines to slow down and enter orbit? If that happens, we would see new satellites appear around Jupiter after March 16th. Jupiter currently has 95 known moons. If we suddenly detect a 96th moon that was not there before and it appeared right after 3I Atlas passed by, that would be impossible to explain with natural physics. This is what scientists call a technological signature. Discovering a fresh 96th moon around Jupiter would be clear evidence 3I Atlas deployed something because the direction and magnitude of the velocity kick must be exquisitely designed. Natural comet physics cannot do this. It would require active propulsion. Think about how we actually explore Jupiter. This is exactly the maneuver our spacecraft do. When we send missions to Jupiter, they approach at high speed to save fuel during the journey. Then, when they arrive, they fire engines to slow down enough to get captured into orbit. The Juno spacecraft did this in July 2016. It approached Jupiter at high speed, then fired its main engine for 35 minutes. That burn changed its velocity by about 540 ms. That was enough to get captured by Jupiter's gravity. For 3I Atlas fragments to enter orbit, they would need velocity changes of tens of kilometers per second. That is way more than what Juno did, but the principle is exactly the same. You use active propulsion timed precisely to cancel your incoming velocity. The difference is we would be watching this happen to an object we did not build, an object that supposedly formed naturally billions of years ago in another star system. Have we ever seen natural objects get captured into orbit this way? Actually, no, not with interstellar objects because we have only detected 3 of them total: Oumuamua in 2017, Borisov in 2019, and now 3I Atlas in 2025. Oumuamua was the first. It passed through quickly and showed some weird acceleration, but never got close to any planet. Borisov was the second. It looked like a normal comet. It had a tail and behaved exactly as expected. It passed through the solar system and left. No anomalies, no unusual trajectory, just a regular comet from another star system. 3I Atlas is completely different. It is massive, it has 16 documented anomalies, and it is heading toward a planet with precision that seems designed rather than random. The jump from Oumuamua and Borisov to 3I Atlas is enormous. The first two were interesting but explainable. 3I Atlas is raising questions we have never had to seriously consider before. We have seen temporary captures in our solar system. Sometimes an asteroid will get captured by Earth's gravity for a few months before escaping again. But these are objects already in the solar system, moving at speeds that match Earth's orbit. They are not interstellar objects coming in at tens of kilometers s. For an interstellar object arriving at these speeds, natural capture is essentially impossible without something slowing it down. If new objects appear in Jupiter's orbit after mid-March, we have only two options. Either we are seeing physics we do not understand, or we are seeing technology. Let me talk about what most astronomers actually think is happening here. The natural explanation is pretty straightforward. 3I Atlas is an ancient comet from another star system. It formed billions of years ago in a planetary system around a different star. At some point, it got ejected. It has been traveling through the galaxy ever since. Eventually, its path happened to bring it into our solar system. The path is calculated using Newton's laws. There is no design, no intelligence, just physics. The jets we see are ice sublimating when solar heat hits the comet. The non-gravitational acceleration is those jets acting like tiny rockets. This is completely normal comet behavior. The fact that the trajectory takes it near Jupiter's Hill radius is just coincidence. The fact that it passes near Eupheme the next day is just coincidence. With billions of years and countless interstellar objects wandering through the galaxy, eventually one of them will have an unusual path. This is that one. Most scientists would say this is by far the most likely explanation. Even Loeb estimates maybe 95% probability or higher that this is just a weird comet. But he also points out that 5% is not zero. And when you stack up 16 different anomalies and when the trajectory math comes out to 1 in 26,000, it is worth actually checking instead of just assuming. This is where things get really interesting because someone actually asked the CIA about 3I Atlas, and the response raises some serious questions. A researcher named John Greenewald Jr. runs the Black Vault. This is an archive with over 3.8 million pages of declassified government documents. Greenewald has been filing Freedom of Information requests for decades. In December, he filed a request with the Central Intelligence Agency asking for any assessments, reports, or communications about 3I Atlas. You would expect either, yes, we have some reports, or no, we have nothing. On December 31, 2025, the CIA responded. They said they can neither confirm nor deny the existence of records about 3I Atlas. The fact of the existence or non-existence of such records is itself currently improperly classified. This is called a Glomar response. It is named after a ship called the Hughes Glomar Explorer that the CIA built in the 1970s to secretly recover a sunken Soviet submarine. This is the same type of response the CIA gives about covert operations and classified weapons programs. This is not the response you give about a space rock. NASA said in November that 3I Atlas is definitely a comet of natural origin. So why would the CIA classify their assessment? This is standard protocol for black swan events. Very low probability, but extremely high potential impact. Even if experts think chances are tiny, if there is even a 1% possibility this represents technology from another civilization, you have to verify. But you cannot announce you are investigating it because if it turns out natural, you lose all credibility. So you classify everything. Let NASA make public statements while you run your analysis behind the scenes. The timing is interesting too. Loeb published his Hill radius calculations in late December. Days later, the CIA issues this classified response. This suggests government officials saw the same numbers. They recognized the implications and decided classified treatment was appropriate. People would immediately assume the government knows something they are not telling us if they released redacted documents. so the Glomar response keeps the lid on. Let me tell you why this hill radius precision is not the only weird thing about 3I Atlas. There are 16 documented anomalies. When you stack them all together, you start to see why some scientists think this deserves serious investigation. First, it has an anti-tail jet pointing toward the Sun both before and after passing closest to the Sun. Second, its rotation axis is aligned within 8 degrees of the sunward direction. Third, its orbital plane is aligned within 5 degrees of the ecliptic plane. Fourth, the gas it releases has way more nickel compared to iron than any known natural comet. The ratio matches industrial alloys. Fifth, the anti-tail extends over 400,000 kilometers. Sixth, it shows non-gravitational accelerations that do not match normal outgassing patterns. Seventh, its arrival direction was within 9 degrees of where the famous WOW signal came from in 1977. Eighth, it rotates once every 16 hours, but the jets stay pointed in fixed directions instead of getting smeared out. Ninth, it has way more carbon dioxide compared to water than normal comets. 10th, it releases different chemicals from opposite sides. 11th, it is brightening way faster than it should be. 12th, it is turning blue, bluer than the Sun itself. 13th, it is massive, over 1 kilometer across. 14th, mass loss calculations show it should be losing more material than its total weight. 15th, images showed one solid nucleus despite thermal stress. And 16th, this hill radius precision and the Eupheme encounter. Any single one of these might have a natural explanation, but 16 different unusual behaviors all in the same object. That is what makes this so interesting. If you watched to the end, please drop me a like and hype and let me know your thoughts and theories down in the comments. God bless you and have a great week.